In today's video, I'm going to be explaining the general binomial theorem. This basically says that for a plus b to the n is equal to this function right here. This function right here. I promise that I'll explain to you very, very simply. Now, a plus b to the second is how much? You know that is equal to a squared plus 2ab plus b squared. Am I correct? And for cube, it's equal to, for the same formula, a plus b to the third or cubed is equal to a cubed plus 3a squared b plus 3ab square plus b cube. This function does all of that. How, you may ask? I'll explain it to you very simply. First, this Goliath right here just adds all the possible values, and this function is n choose k, and what that means is that there are k possible blanks. These are all k possible blanks, and there are n possible solutions, and there are n possible options to fill in the blanks. So 1 can go here, 3 might go here, and 4 might go here. What the function n choose k basically does is that it evaluates how many different options we have to do the same thing. And let's give an easy example. A plus b to the second, that's equal to this function that adds all of the possible values. N is equal to 2, so we write 2 here. N choose k, so it's equal to, for the first term, it's equal to 2 choose 0, and a to the power of n minus k plus b to the k. K is equal to 0, so we can just remove the b term. K is equal to 0, so we can remove the b term, and a to the power of 2, because it's n minus k, and n minus k is equal to 2. So we can rewrite that as a squared. And the second term is going to be equal to 2 choose 1. So this is the coefficient of this whole term. So it's going to be equal to, there are two possible solutions, because there is one blank and there are two possible options. This might come here or this might come here. So there's two possible options. So it's equal to 2 is the coefficient, and n minus k is equal to a to the first, or just a, and b to the first, because k is equal to 1 in this situation. So we add that, and then what do we get? Now in total we've done until k equal to 1. Now we have to finish by doing k equal to 2, and 2 choose 2 is equal to 1. So we can rewrite this. We don't have to write that, because 1 is the coefficient, and we don't need to write the coefficient if it's 1. So, and n minus k is equal to 0. So 0 plus a to the 0 plus b to the k. B to the k is equal to b square, and we can just remove the a. So we add all this up, and what do we get? A plus b whole square is equal to a square plus 2ab plus b square. That's how this function basically works. We can take n equal to 3. N equal to 3 we all know, so let's try n equal to 4. n equal to 4. If we try, then we'll get a really different answer. This time I'm going to go a little bit faster, but I think you understood. Now, I'll show you a cool thing about this n choose k function. It's just equal to the Pascal's triangle, or this right here, this triangle. You add these two and you get the thing below. You add these two, the thing below, this is equal to 0, this is also equal to 0, and then this is 4, 6, 4, 1, 1. For n is equal to 2, we found the coefficients are 1, 2 and 1. So this is n is equal to 2. And this is n is equal to 1, which is just a plus b to the first is just a plus b, right? So, and this is n equal to 0, which is just 1. And here is to the fourth. When we write to the fourth, we get this function right here, and we get these coefficients right here, n equal to 4, these ones. So we don't have to do n choose k every single time. You can just write the coefficients using Pascal's triangle. So these are the coefficients, we know that already, and the rest of it is pretty simple. You just add all this up because of this, and these functions are equal to a minus, so a to the fourth, a cubed b, a square b square, a and b cube, and finally b to the fourth. This is how we expand the binomial to the fourth power. We can use this for any power n. You can start experimenting, but in this video I have an additional problem. The additional problem is x to the y is equal to w and z plus z is equal to y. It's actually a problem that I made myself, and z plus 1 is equal to 6 and x to the x is equal to z to the n plus z minus z to the n plus 1. Remember, n stays constant here. And then we have this. How do we solve this? We can solve this by substituting z equals 5, because this right here, and we can just solve for z by putting 1 on the other side, so z is equal to 5, and we can substitute this for 5. We can substitute all these for 5. 5 plus 5 is 5 to the n plus 5, and this is 5 to the n plus 1. Because 5 plus 5 is equal to y, we know that y is equal to 10. Y is equal to 10. So we can remove that because it's not useful anymore. And then we just need to solve for this right here. We can, because we are subtracting an n to the 5 and adding an n to the 5, we can just remove those, and 5 minus 1 is equal to 4. So x to x tetrahedron or something, I don't really know, to the second is equal to x to the x, which is equal to 4. Now try to find the value for x. X to the x is equal to 2 to the second, because 2 squared is equal to 4. So now that we know all, and we know that x to the y is equal to w, and x is equal to 2, and so it's 2 to the 10 equals w, and 2 to the 10th is equal to 1024. That's our answer right there. Thank you for watching. Bye guys.